click, 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 talking and transition and hello.
Click, click,
Talking
and transition.
Nope, quiet. Bad phone. All right. At least we know the audio is working. So how are you doing, Mama?
I'm doing all right. I'm still crunchy. Okay, I'm done with that. I guess I can pull out my microphone. Where is it?
Say again.
So I guess I could pull out my microphone. It can push into the earpiece.
Oh, okay. Yeah, I've had some like that.
And then those will also rotate so it lays flat, which makes it, if I pack it up, it'll be much nicer.
Yeah. Because I think the ones that I gave you, it was just like bendy. Yeah, it didn't have an option to either remove the microphone like my current set, or because I have it completely removed since I have the studio mic type thing, although you can't see it in stream. Yeah. But yeah. I think I've gotten the stuff set up in the background because I decided I wanted to be late today. But yeah. Alright, anything you want to talk about before we start doing some Sudokus?
Not that I know of.
Alright, I don't have anything. So, Sudoku puzzles. Alright, so I don't think we got caught in the middle last time, so this one is Octillo, or maybe Octio Blossoms by Cheerful Janba. Maybe that's Cheerful Janba. Normal Sudoku rules apply. Place digits 1 to 9 once in every row, column, and box. German whisper lines, 2 cells connected by a green line, must have a difference of at least 5. Dutch whispers, 2 cells connected by an orange line, must have a difference of at least 4. Kropki dots, cells connected by a black dot have a 2 to 1 ratio. Cells connected by a white dot are consecutive numbers. XV, cells joined by an X or a V, must sum to 10 for an X or 5 for a V. And red lines are the Octio Blossoms, and the yellow sun are purely cosmetic. Okay, so these green lines are the German whispers. So if I were to say place a 7 here, then it would have 2 and 1 surrounding it. Although clearly you can't put a 7 on a V because that sums to 5. So that might be a 2 and a 7 here, and then you'd have a 3 there and 4. For the white Kropki dot. Black Kropki dots are 2 to 1, so if I were to say place a 4 here, then I would either put 2 or 8 on the other side. And then the orange lines are Dutch whisper lines, which are similar to the German whisper lines, but they have to differ by a minimum of 4. So if I were to place a 5 here, I could put 1 and 9 on opposite sides, and a 6, which you couldn't put in the middle of unless you're careful, and in the middle of a German whisper line, you could put 1 and 2 around a 6 on the Dutch whisper line. I think that is the rules explained. So I'm just going to go ahead and see that X there, and since those have to sum to 10, 1 and 9, which is going to make this 6, 7, or 8, although it's not a 6 because you can't put a 1 here. This one is going to be 6, 7, 8, or 9. 6, 7, 8, or 9, although this can't be a 6 because you'd put 1 on both sides, and a 6, 7, 8, or 9. The others are 1, 2, 3, 4. Well, that one's not a 1, that one's not a 9, because that can't be a 9, but that could be. here we've got 1, 2, 4, and 8, where you have 2 or 4 in the middle. 1, 3, or 5 across the white crappy dot. 2 or 4 here. And this has to be minimum 7.
In box 6, that can't be a 4 beside the 9 because it doesn't go to another 9.
True. It would have to be a 9 on both sides of the German Whisper.
Column 5 between box 2 and 5, that white prop key, it can't be a 9 because 9 would have to go to 8, and it can't go back up to 9, and it can't go to 7, so that can't be a 9.
9, 8, 7. But you could do a 9 here and then 8, 7 that way. So this one can still be 8. But this one can't be 8 because it doesn't have 7 or 9 up there.
Right.
4 and 3 gets removed from these two. Four or 6, but otherwise 5, 7, or 9, not a 7.
Yeah, row 3 has... No, it doesn't, because that if it's a 4, it could go to a 5. I was going to say it's going to have 4 lows, but that could go to a 5.
This can't be 4 or 5. For multiple reasons, it can't be a 5. So the only even digit on this group is a 6. Which means, because it's the only even digit...
Well, it can't go 8. 7, 6, 5.
Yeah. But it could go 7,
so
8,
the
9.
The center of it can't be 6.
Right.
And it can't be 6, 5, 6.
Right.
So it can't be 6, 5.
7, 9, 8. 7.
9 pairs with 1 on the X. There's dots too. Ox 2.
Right. That is not necessarily fixed. Well, this can't be 5 or 6. So this is 5 and 6.
The white crappy dot in box 3 can't be 1.
Because it wouldn't be able to pair with the 2. So that's a 1, that's a 9, that's a 7. 9's not allowed. 6, 1, 4, 3. 9, because of the 4.
Electron is here. It says, hello, you two. Hello,
Hey, Electron.
I didn't even notice that popping up until I glanced over.
Now this is a 4 now. That's not 1, that's not 2 or 4. So this is 8 or 9. It's not an 8 because the 8 up there, so that's a 9. This cannot
be 8. That can't be 8.
1, 2, 4. Or 2, 4, 8. So that's still not fixed. But this is minimum 6, not a 9. Oh, that's not a 9. That's low, so 6, 7, 8, 9. But then this can go 1, 2, 3, 4, 5, but not 1 or 4. So this couldn't be a 2, because it wouldn't be able to connect to that.
Right.
But we could go 9,
the other
5,
side of
1.
Right. The other side of that X can't be an 8 now.
Uh, 8 minus 4 is 4. 1, 2 pair makes that a 9 and a 1. So that's a 5. That's a 9. Doesn't impact either of those. Oh, 2, 4 makes that a 1, a 2. 8, a 4, a 2.
Row,
No longer
row
1.
7, column 6 can only be 1 or 2. Okay, you just saw that. Okay, never mind.
5, 6, 7, 9. That's an 8. 3. 8. 7. 6. 2. Not 2. 3, 4, 5. Well, that's 3, 4, and 5. 3. 6, 7. 8, 9. 1 or 2, 4. Wait, that's 1 or 4. 1, 4, or 5. These 3, I need 2, 5, 6. This is 4 or 6.
Going from box 4 to box 5, the 5 on the Dutch Whisper line, but also has an 8 with it, so it has to go down.
1, 2, 3, 4, 5. 2, 5, 8, and 7. 4 and 6. Well, it's not 4
No,
and
4 and
6,
5.
but that's 4. 2, 3, and 6. 3, 6, 2. 6. 1, 2, 3, 4, 5, 6, 7, and 8. 7 and 8. These 3, 5, 7, 6, 4, 1, 9. 8, 2, 3. 4, 5, 6, 7. There we go. Speedy puzzle. And the next one is Putting Green 2 by Brunel. Normal Sudoku rules apply. A purple line contains a set of consecutive digits in any order. Adjacent digits on a green line differ by at least 5. Adjacent digits on an orange line differ by at least 4. A white dot joins consecutive digits. Digits shown in a circle appear in at least one of the surrounding cells. So that means we've got to put a 1 around one of those. These have to still be consecutive. 3 would be paired with 4 or 2. And then green lines differ by 4, so a 6, or excuse me, green lines differ by at least 5, so 6 would force a 1, but then after a 1 you can have 6, 7, 8, or 9, although you can't have the 6 see itself, so you'd have to have at least one of those. purple line is Renban. So we know we've got a 1 on it, so it's going to go 1, 2, 3, 4, 5, 6, and 7 in some order. We don't know exactly where those are going to be. And orange line is, again, a German whisper line. So, or excuse me, Dutch whisper line.
Yeah.
So if I put a 5, it's surrounded by 1 and 9. Not mean to do that. But then that 1 or 9, and then if I were to place a 6, I can now place that in the middle, because that would have a 1 and a 2 on either sides. I don't think I missed any of the other rules, so...
For box 5, there's only one spot for a 5. And box 4, there's now only one spot for a 5.
Let's just go ahead and start painting this as being purple and green. That green, purple, green, purple, green, purple, green, purple, green, purple, and green. Well, that means this one is purple. We've already got 4 greens. And we've got 4 purples now. So these 2 are both green. And 1, 2, 3, 4, 5, 6, 7. We only have 6 and 7 as high digits. So purple ends up being red, and green ends up being blue. Well, I still need a red in this row. It can't be either of those, so it's going to have to go there. So that has to be blue in 5, and that has to be blue.
In box 4, the red that's on the left has to be a 9, because 9's the only one that could go to 3 different blues.
1, 2, and 3 for 8.
Oh no, 8.
Oh, but this one couldn't be 4.
Right.
So that is going to have to be 9. And we've got 1, 2, 3, 4. This one cannot be 4. So this can't be 4.
Neither can that one. At the bottom one that you just put a 6, 7, 8 in can't be 6, because it would have to both be.
True. No. Now, this one can't be a 6, that one can't be a 6. So that is 6, and that makes both of those 1. This can't be a 4. This can't be a 6. Those is 4, that's not a 1.
Can't be 6 or 9.
6. It can still be 9.
No, the one on the left. Can't be 6.
Oh, right, because it's got 2 neighbors. I, for some reason, only saw the downward one.
Yeah, there's just a slight lag, and so sometimes you're ahead of me before I say it, so you're not on the spot I was talking about anymore.
4 has to be one of those two, so it's not that one. Even if I were to put a 5 on here, it would still be surrounded by 1 high and 1 low. But if I didn't put a 5 on here, it would have to be 2 highs and 2 lows. But I can only put 1 on here. So one of these two is 5, which is going to place a 5 here. And the 5 will be surrounded by 1 and 9.
The bottom of column 3 can no longer be a 6 because the one at the top of has to be at the top of column 4. So that 6 can't be followed by a 1.
Right. That can't be a 4. Oh, 2, 3 pair, 4. That doesn't work. Because that can't be a 4, that can't be a 4, that can't be a 4, so that has to be 4, but that's a 4. So did I mess up the 5s? Because this was true already, that none of those could be a 4.
Right.
And it couldn't be here, because I've already got all the reds. I guess you could put 5 on the end, because it would go 5, a high digit, and then a low digit, and another high digit. So that conclusion that it had to be 5 surrounded by 1 and 9 was wrong. So I could go 5, 9, 3, 7, and be fine. So now that the 1 is no longer forced here. Although neither of those is a 1, so that's a 1. So now 1 is forced onto here. Those two can't be a 6. This could be, place 1 there. One of these two is a 6, so that is a 1. So that can't be a 1, because it has to be one of those two. 2, 3 pair, 2, 3 pair makes that a 1, 4 pair. 2, 3, 6, 7.
Box 5, column 4. The 7, 8, 9, the red, can't be a 7 because it would have to be bounded by 1 and 2, and there's not a 1.
Oh, but the 5 has to be next to a 9. The 9 will be followed by 2 or 3. But that all of those are possible there. 7, 8 pair places a 6, places a 1, places a 7, takes 7 off of those two, places an 8, takes a 1 out. That's a 9, that's a 4, that can't be a 4, that's an 8, that's a 7, 2, 3, not a 3, 8, 7, not 7 or 8, excuse me, 8 can come off. Those two aren't 2s, so that's a 2, that's a 3, that's a 1, those aren't 2s. 3 can't go to 6, so this is 5, 8, 6, 3 and 6, 9 and 3. Two, 2, 7, 3. None of those are 7. This one's a 9, that makes that 8. Those just aren't 8. That is, that isn't, that isn't. Can't be a 7 because it's bounded by both 2 and 3. So that's 6, 9, 7, 8. These
Column
two.
4 and 7.
You said 4 and 7?
Yeah.
This is a 5 because it can't be a 3. So I've got 2, 3, and 6. So that's not the 6. That is 2 and 3. What are these two? 2 and 9? Um, 4, 5, and 7.
Row 7 is 3 and 6. Row 8 is 4 and 5.
All right. So
1, 5, and
7.
7. 3, 6, and 8.
2, 4, and 9.
4, 9.
Okay, well this one has to be low. So you can't put 3, but you could put 6 or 8. That one has to be high, so this can't be a 7. This can't be
Neither
a 5.
one can go to 5.
So 1, 5, 7, 4, 5. This one's going to have to be red. This one could be a 5. One, 8, 9. Not a 9. So it's 1 or 8.
Okay, if you go left, but since the elbow there and the center digit of box 3, let's go that way. Neither one can go to 4 and 5 can't go to 6.
That's true. So that's a 9. That's a 4. That's a 2. 9, 5, 1, 7, 5, 4, 1. The 6 pair leaves a 7 in the column.
Row 1 is 2 and 4. Eight.
This is 3 and 6. No, that's a 6, so that's a 3, so that's a 6. 3, 3, 6, and 8. I think everything's painted. Alright, then that was the 2 speedy puzzles I wanted to take a look at. And then we still haven't finished all of Elytron's new puzzles, so let's go and do those. German royalty's scaring me with its 4-star rating. So maybe we just do the grass is always greener in the fog, and between a relative and a stranger. And then we'll see how we're doing on time after those. So, the grass is always greener in the fog. This puzzle is a sequel to my recent puzzle 19 Shapes of Grey, where I was surprised by how well it went. Since I don't like creating a puzzle with exactly the same rule set, there's an extra rule in this puzzle introducing green shapes. If this puzzle is also well received, I might make more, because I still have some ideas in mind. Okay, well, I'm just going to go ahead and read the rules over here. So, this is The Grass is Always Greener in the Fog by Elytron. Normal Sudoku rules apply. Digits separated by a black shape are in a 1:2 ratio. Digits separated by a white shape are consecutive. Digits separated by a gray shape are neither, and green shapes don't have a restriction. Shapes are made up of semicircles and semi-squares, resulting in either a full circle, a full square, or a circle square. These may be rotated in any direction. Digits separated by a circle add up to 9. Digits separated by a circle square add up to 12. Digits separated by a square add up to 15. Fog. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. No guessing is required. Oh, it just grew. I was wondering why I was trying to be like, okay, well, what's the 4th shape? Well, just because you have a 4th color doesn't mean you get a 4th shape. I feel a little silly. All right. So these aren't in any particular pattern, but the squares here cannot be
both full squares.
Right. Because they're so we know one is 15 and the other is 12. So this is 6, 7, 8, 9, but it can't be a 6. So the 15 is going to be 6, 7, 8, and the 12 is going to be 3, 4, or 5.
Yeah, Elytron said the one idea I have in mind is to add a 4th shape. That's not in this puzzle.
Not yet. Although if you add a 3rd half shape, that gives you a total of 6 possible shapes that you can do. But maybe you just make the 3rd one non-ambiguous. But I'm sure you've already thought about how that would work.
Okay. The circles.
Yeah.
Okay, circle squares add to 12. They cannot all be circle squares because that would be 36. And then we would need 3 that add. Well, no, that could work. Add to 9. Never mind. I'm dumb.
Yeah, you could do a 6 and a 1-2 pair.
Yeah. Because 12. Actually, adding to 12 none of those can be 12. So 1 and 2 are the outside corner, are the two corners that are a 1-2 pair. Cells 1 and 9 in that box.
Oh, right. Wait,
Or
wait,
a
wait.
1-2 pair. Well, because circles add to 9. Oh, no, circles add to 9. Never mind.
Yeah.
Like I said, I'm dumb. I was still stuck on everything's a minimum 12.
Mm-hmm. So if there are 4 ways to make 9. Okay, hold on. This is an Elytron puzzle. All 3 of these are multiples of 3. The 9s, the 12s, the 15s.
Right.
So let's do some modular arithmetic. 45 divisible by 3. Take that out. We know that's divisible by 3. We know that's divisible by 3. We know that's divisible by 3. So the remainder must be divisible by 3. What's that leave us? Not a ton. We know those 2 are divisible by 3, and those 2 are divisible by 3, so what's the whole group?
Well, the problem is if it's 9 and 6 for the 15 and the 3, then they sum to 18.
Yeah.
If it's 7 and 8 for the 15, 7 and plus 7 and 5 is 20, or plus 8 and 4 is 19. So
we can't make any conclusions based off of this triangle. Well, that was kind of sucky.
well,
Okay, well, if these are both 12s, we get a 1-2 pair. If we get
right.
one that is a 9, so that would be, well, if I do the 9, the 12, and the 15, that's still 36. And I still get 9 as a remainder.
What combination go onto a circle or square, circle square, if you can't use 7, 8?
Say again? What combinations go onto a circle or circle square if you can't use 7, 8? Well, it would be 9, 6, and 3. Would be this.
Which are all zeros.
Right. And we'd end up with those 2 being zeros as well. I mean, I guess technically, you can use 4 and 5 on a circle without 7 and 8.
Oh, Electron, I meant what would go onto the outer half circles if you had a 7, 8 on the square.
Yeah. So, to get 12, you can't have 6 ever. 7 and 8 take out 4 and 5. You would have to be 3 and 9. And then the other...
There's nothing left for a 12, would have to be 9.
Which is... yeah, because 3,
4, 5,
4, 5,
or
6.
3, 6. It can't be 3, 6. It would have to be 4, 5. But 4 and 5 would, one of which would be used in the 12 with the green circle, the green squares.
Right. Okay. So that means we have to have 9, 6, and 3. And now we get a 9 up here. 3 and 6 is out. We get a 12 over here. 3 and 9 and 6 is out. But we're just left with that. Okay, so this is 6. Excuse me, it's 9. 6 and 3. And then we don't know what that one is. But this... we know they're in a 1-to-2 ratio.
Right. And you can't do a 1-to-2 ratio
That makes 15.
Yeah, none of that makes 15. I had to think about that for a second. It's like, wait a minute.
Because it would have been 5 and 10. So we know that this is 12.
Right. Which would be 4 and 8.
Yeah. Which takes 4, 8 off of this one, because it's also 12. And this one's 9. 4 and 5 and 2 and 7. So 1, 8. 1, 8 takes off 1, 8 as well. And now I'm left with 2.
And 4.
Which, that's a 2, that's a 4. Not a 2, not a 7. Okay, well, if it's 9, then we've got 4, 5, 6, and 8. 7. You would think I would know how to do math by now. And if it's a 12, then we have 7, 8, 9. Well, 9 and 6 both paired with 3. Well, it can't be 12 and go 5 and 7, so it would have to be 8 and 4.
Well,
wait a second. We know that this is 12. It can't be 9, because if it was 9, a 5 would put 4s on both sides. So this has to be an 8, paired with a 4, paired with a 5. Nine. 4 and 5, 8 and 1, 6 and 3. And then if it's 12, never a 6, 9 and 3, 4 and 8. And it couldn't be 5 and 7. So that has to be 2, 7. So that gives us 5 and 7. And then what's left over? 1 and 3. And then this could be 12. 3, 4, 5, 7, 8, 9. But the 3 means 3 and 9 is out, but then this sees 4, 5, 7, and 8, so that can't be 12. 6, 7, 8, 9. 7, 8 is out, has to be 6 and 9 for 15. 5, 1.
Eight goes on the bottom of box 3.
So then this is B1, 2. So that's a 7, that's a 2. Well, if this is 12, then we would get a 3. If it's 9, we also get
We
a
get
3.
a 3.
So that's 12. So that's a 9, that's a 6. 3 and 9. 7, 4, and 6. Consecutive would be 4 and 5 for 9, but it can never be 12 because you can't make consecutive digits add to 12, so that has to be 4 and 5, which places 4s down here. Gray circles can be neither consecutive nor in a 1 to 2 ratio. Take those out for a second. So if this is 9, then 2, 7, 3, 6, and 4, 5 is out. If it's 12, 4 and 8 is out, 3 and 9 is out. So that would be 5, 7. Four and 5, 3 and 6, 4 and 8, 3 and 9.
What's
Well, 4 has to be down here, but it can't place it on either of these.
right? But
So
on the
that's a
center, why is there a 9 on the gray circle? Oh, because it's neither. Yeah,
Well,
but it would have to add the 9 or 12, and it was just a boo boo.
Yeah. Okay. I'm getting lots of Facebook dudes, but they are not getting onto my phone yet.
Okay, a white square.
That's 15. Consecutive, 7, 8.
Right.
So 7 or 8 must be used up in here, so 7 and 8. 7, 8, 1, 8. Apparently that one's a 6, 4, 7. 6, 9, so that's a 6, that's a 9, that makes 12, so that's a 3. 1 and 3. 5, 6, and 9. This one is a 2. This one is a 1. And then I still need 4 and 5. Five and 5 places 5. Hmm. 4, 5, 4, 5 places 4 and 5. 6, 7, 8, 3, and 6. Well, that's not particularly helpful. So,
It's messy.
yeah. Hmm. Six, 9, and 3. 7, 4, 5, and 8. 4, 5. 4, 2, 5, and 7. And also 4 and 8. So that's a 1. That sums to 9. So we get 1, 2, 4, 5, and 7. 1 and 2 takes out 7 and 8. These have to be in a 2 to. This is a 4. Paired with a 5. That's 12, so that's an 8. 5 and 8 is out. 5 is out, places a 5. That's a 5, so 4 and 5 is out. That's a 4. 4 and 5, which actually just places those. Well, that can't sum to 9, so it's 12, so this is 7 or 8. That's 1 and 8. 2, 7 pair places an 8, a 7, a 5, 4, a 2, a 9, a 5, a 7, 8, 4. That's 15, so 6, 9, and a 3 left over. 2, 7, 6, 9, 6, 7, 7, 9. Actually, none of those are 7, so 7 and 2, 1 and 2. These 3 are...
6, 7, and 9.
That's a 9, that's a 6, that's a 7. I still need 1 and 3, 9 and 3. This is a... no. 6, 9, 6, 2, 9. I don't see a 3 or a 9. I don't see a 2.
Or a 3.
There we go. First try. 1, 6, 7. These, that's 1, that's 7, that's 6. 8 and 1, and 1, and 2, and 8. There we go.
Almost didn't have to guess digits. Or maybe that's just guessing what the digits are under the fingers.
I mean, at least I wasn't putting that into the fog region. It was just getting the last digit in there, and it's just I didn't want to scan for it. My brain's not too fond of the scanning. Row 9. 3, 4, 8. 6, 7, 9. 5, 1, 2. Very nice. average? I feel like the hardest part was considering the top part.
Yeah. If Eltron
Um,
hadn't pointed out the 7, look at the 7-8.
yeah. The 7-8 was the more restrictive of the two, although eventually we would have had to probably just consider what that would have done. So yeah. Putting it into the fog would be painful to watch, especially at like the break-in stage of a puzzle. And that would
Oh, yeah.
I would be I would admit defeat before I start doing that sort of thing. But yeah. I guess the one part that I felt was like a bit trickier to see was this row, seeing that this one was done. Although if I had pencil marked these four, which I had considered doing earlier on in the puzzle, then these three would have differentiated that a lot sooner without needing to just simply be like, well, maybe this is the row I need to look at. So because we had this being most of the way done, and so it would have just been 4 digits, and then that would have seen that a lot sooner. But yeah, I feel like this one was a lot easier than the first time we did it, or not necessarily the first time we did it, but row 2, column 2.
Yeah, for the break-in.
Yeah, but yeah, um, lost my train of thought, but I think I was close to the end. I think it's mainly easier because you start getting used to the rules. Yeah, right. Because last time we took a lot longer considering all of the possibilities. But I do remember also on the previous ambiguous shapes puzzle that it we did get speedier with the possibilities. But yeah. All right. Then take that one out. I guess I'm not sure why I'm taking it out necessarily, but all right. So then we've got between a relative and a stranger. So this one is Electron's submission to Skojo's setting prompt this week, where the goal was to make a puzzle build up a snake loop where the puzzle has a maximum of 10 clues on the grid. All right. So, Between a Relative and a Stranger by Electron, normal Sudoku rules apply. Draw a one-cell wide snake of orthogonally connected cells. The snake may touch itself diagonally, but not orthogonally, and must visit all boxes exactly once. A digit on the snake that is not an endpoint is co-prime to exactly one of its snake neighbors, meaning their greatest common factor is 1. The two endpoints of the path contain the same digit, and exactly one of them has a co-prime snake neighbor. Cells separated by a white dot contain consecutive digits and are not on the snake. Clues outside the grid indicate the sum of the digits along the indicated diagonal. Digits can repeat along the diagonal if allowed by other rules. Okay. Okay. Well, we know that we've got walls surrounding these. And our snake, well, it's got to enter and exit this corner. Oh wait, it doesn't have to enter and exit, it's a snake. Well, we know there's an endpoint up here. So that is the snake there. Because we know that the white croppy dots are consecutive and not on the snake. So $39. Oh, that one needs to be included. Cannot find some. Well, that's helpful. Okay, well, 1734. Oh. And I mean, that's what, 51? And then you add a couple of nines and you get fairly high. I mean, this one's minimum 7, so we've got lots of flexibility there. My main advice would probably be to just think about how a snake could work/look before doing anything else. I mean, if we...
It has to hit every box, right?
Yeah. If it doesn't end in this box, then it looks like this. And then once it leaves this one, it can't come back in. Okay, well, I guess I want to consider this corner then. Are there enough digits?
More in the sense of the digits on the snake, less about the shape of it.
True.
Maybe go through an example or two.
So the way the snake works is if it's not an endpoint, it has one neighbor that it's co-prime that is co-prime with, and the other neighbor is the opposite of co-prime. Because the opposite of co-prime just means it has some greatest common factor greater than 1. So, okay, let's say I put a 5 on here. Well, 5 isn't going to have a neighbor that it shares a factor with, because 5 is prime, then the only way that it has a greatest common factor is if its neighbor is a multiple. So that would put 5 in here. Same with 1. You can't have 1... I mean, 1 is automatically co-prime with everything. So 1 would end up in here. 1 being in here would automatically place 2, but if I just consider 2 being a possibility, 2 is prime, but we have single-digit multiples, and then you would just put an odd digit as the other value.
7.
Yeah, 7 has the same problem as 5. But now I've run out of... I have too many possibilities in this group. So we cannot go in and out of this box. So we only have a single entrance. Now, okay. The digits being out here, or the fact that there is clues outside the grid indicate the sum of the digits along the indicated diagonal. Digits can repeat along the diagonal if allowed by other rules. Okay, the rules don't state that this is or is not a possibility, but can the snake go outside the grid? Just because those were drawable squares?
I wouldn't think so.
The extra space outside the grid is to take notes, because somebody asked me to add that. Okay. So if I wanted to... okay. I'm not sure whether or not I need to take notes, but I just wanted to confirm that, because it didn't say that it couldn't in the rules. But just because it didn't say it couldn't doesn't mean it could. So I was concerned. Anyway. But yeah, so we know that 1, 5, and 7 are automatically co-prime with both neighbors. So you couldn't even put those on the snake. 2 can go with 4, 6, or 8. And then 3 pairs with 6 and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these aren't allowed at all. And then we sort of have 2 groups.
Oh, yeah. But they could be on an endpoint. Because Electron asked, could you put them on an endpoint?
No. If you're referring to 1, 5, and 7, we couldn't put them on an endpoint because the endpoint, we know both endpoints are the same value, but one of the two endpoints still has to have a neighbor that it's co-prime with, and therefore the other is not. They sort of still have the same rule as the non-endpoints.
Ah, okay. Exactly. Just wanted to make sure that logic is clear.
Cool. Okay, well, we know that the head of the snake has to be in these two. And since we know that once it leaves, it then cannot enter again, we know the snake has to do something like this in those. So to get from wait a second. 6 isn't going to work. Because the only set of values that 6 is co-prime with, because 6 is even, so it's part of the 2, 4, 6, 8 group, and is a multiple of 3, so the 3, 6, 9 group. So the only thing that 6 is co-prime with is 1, 5, and 7, so 6 is actually excluded. So these are my two allowed groups. So it alternates between 2, 4, and 8, and 3, 9. So 1, 5, and 7 aren't allowed on the snake because they don't have any common factors with anything. And then 6 isn't allowed because it has too many common factors. Let's see. Can you give me an example, Snake, with some different digits after you're done with that thought? That is nice. Fine. That was what I was hinting towards. Cool. So yeah. Okay. So we know the snake has to be from these 5 digits. So how? We know the end is here. Okay, so then it goes from here to there, from here to here, and then we know that this one goes into here, so we have to cross this way. So this is a requirement. Okay. This yellow line is impossible to see because of all of the other colors that I put on here, so let's go with the black line. So that's the general path of the snake. We can't be orthogonally connected. I'm taking too many notes. Alright, let's get rid of those, because they're probably not going to be helpful. I can get rid of these lines now. And then do that. And then if I just remember this. Oh, well, because I can't be orthogonal, I can't take up these spaces, then that has to be there. Five, six, 7, 3, 9, 2, 4, 8.
By the way, I would probably draw this shape using fully colored snakes. I think that makes it a bit easier to make notes where it does and doesn't go. But if the line tool is easier for you, I'm fine with that. Do whatever you like.
Yeah, I probably should be doing it this way, because I've got my yellow and blue group. Can't put a 6 there.
Yeah, that's not quite how the digits on the snake work. If you look at that a bit closer.
Oh, right. So I know it goes like this. But blue, yellow, yellow, that doesn't work. Because they have to go, it would go, blue would be surrounded by blue and yellow, and then yellow, blue, blue, yellow, yellow, blue, blue. So this is yellow. And either this is yellow and blue, or this is yellow and blue. But the other one would be blue, blue. Okay, but it is going to go like that. Have to remember that pattern. Okay. If I did yellow, yellow, then this would be blue, blue, and I couldn't go there. But if this went yellow-blue, this would still go blue-yellow, and then I would need another yellow. So the snake is going to go upwards here regardless. Because it would have to be yellow, yellow, blue, blue. I can't do another yellow.
And the next one up is going to have to be yellow. Because if it's yellow, yellow, blue,
blue, yellow. Or yellow, blue, blue, yellow, yellow. Right.
Did the snake go down? In box 9.
Probably. I at least haven't eliminated that as a possibility. If it went down instead, it would have to come out like this. And so let's say we did a yellow here. We would have to make sure that this one was blue. Yellow, yellow, blue, blue. Yellow, yellow, blue, blue. It could be fine if it did that.
Yeah, maybe graying the cells it can't reach. Which I'm surprised you're not doing that anyway. You usually do. At least mark with what can't be.
Right. It can't reach down to there. It can't be these. And it can't be this one. Because we know that this group of 4, because it starts with yellow, has both yellows in it. This couldn't go up and then right, because then it would have to go up and left.
Either way, that one's snake.
True.
Snake seems to take up a lot of growth. Yeah, it pretty much takes it, the majority of it. but it can only take 5 cells. Okay, it can't take cell 9, row 5, cell 9. It can't take that one because then it would have to go across and take at least 3 from there. And it'll have to take at least, and that would be 5, and then you can't get around.
Well, if it went down, it wouldn't be able to get out. So it can't go down here. So this one's yellow-blue.
And it still can't go down
Right.
because it would have to rotate up.
Um,
In row 4, column 4, be a snake.
I don't see why not. Oh, wait. I see why not. Because I need to come across this way, and I've already got 4. So that's not allowed. And this one won't be allowed because if we do it down there, I mean, that would just simply be 2 more. One of these 2 has to be snake because of these. Now this has to be yellow-blue. Now that one can't. That one can't. That one can't. And if we went around here, we'd have to connect there.
That's
So now
orthogonal.
we get, yeah.
And we
now
know
this
that
group
one
of
is
4,
yellow.
Yellow, blue, yellow, blue, yellow.
Well, and it alternates every other one with a skip in between. So it's yellow, skip blue, skip yellow, skip blue. Yeah.
And we could take
Okay.
that one.
Column 7 We have 5 of them. And there has to be 2 yellows together. So in the set of 4 at the bottom, there's already the 2 yellows. So that's blue. Yeah. And this, you could say the same. Yeah,
Here.
with there, because whether that's yellow, yellow, blue, blue, or yellow, blue, blue, yellow. Yeah. And it can't touch orthogonally. So the bottom of, yeah.
One of these 2 is yellow. One of those 2 is blue. But it could be this way, or it could just go straight across. Wait, why do I think one of those has to be yellow? I only have 2 blues in that column. Never mind.
Um. Now let's see. Can row 3, column 1 be part of the snake? Yeah, I was looking at that.
Like this.
Well, let's see. Blue, blue, yellow, yellow, blue, blue, yellow. No, because if you look at that pattern that you've got now, follow the blues and yellows around. Blue.
Blue, yellow, yellow, blue, blue, yellow, yellow, blue, blue, yellow. And I don't think doing it this way or this way is going to change anything, because that's going to go blue, yellow, yellow, blue, blue, yellow, yellow, blue, blue, yellow.
Well, see, and
So,
column 4 has 2 yellows in it.
right.
So either one, whichever one of those is, has to be blue.
Yellow, blue, yellow, blue, blue, yellow, yellow, blue. Yellow, blue, blue, yellow, yellow, blue. Well, I can't go
Well,
up here, so I have to go right.
right. Ah, box 7 snake. Electron. Oh no. Torak. Hi, Torak.
Hello.
Torak has joined the chat. Yeah, look at box 7 for snake.
Well, it's done because the 2
Right,
yellows.
because it would be yellow. Yeah.
blue, blue, yellow, yellow, blue. Blue, blue, yellow, yellow, blue. Oh, this is going to be yellow regardless,
Yeah.
right? Because I could go blue, blue. Well, I couldn't go down. So blue, blue,
Right.
yellow, yellow. And if I go blue, blue, then it's going to be yellow, blue, blue, yellow, yellow. Yeah,
Yeah,
blue,
it
yellow.
is.
Well, it needs the yellow next to it, so that can't go down. It must go left.
And Torak. I usually miss these because they start at 3 a.m. for me, but I'm up early today. Oh my.
That is definitely earlier than I would want to be awake. I have no idea how you were able to wake up this early. Is there a reason you decided to be awake this early?
I'm still up at 3:30 a.m. for this. Oh my.
See, that I can relate to. Okay, it can't be blue blue. It's only one of these. So it either goes blue blue or blue blue.
No particular reason, just couldn't sleep. I can, yeah, I feel that.
That is upsetty spaghetti. I I hate it when I can't sleep. Where can I put 3 and 9 in this box? That's out, that's out. That's not 3 or 9, that's not 3 or 9. So those are a 3 9 pair. These are 1, 5, 6, and 7.
Yeah, column 7. The Kropke dot is from 5, 6, and 7.
1 and 6. Well, I know one of these two is blue, so these 3 are 1, 5, 6, and 7.
Oh yeah, Deltron mentioned the little killers have gotten more interesting. And Torak says row 1, column 5 is determined, I think. Row 1, column 5.
Right, because this is minimum 5 now. 5 and 9
is
is
14.
And that's another 3. So that's 3s and 9s. 3 plus 1 is 4, and 5 is 9. Plus 3 is 12. So I have 3 degrees of freedom. But 1 to 5 is too many degrees of freedom, so that can't be. If I turn this into a 5, and that could still be a 1. Could that still be 15? 5, 10. Oh, it could. 6 and 7 is definitely off the table then.
Check pencil marks of rows 2, column 6.
Row 2, column 6. What's 3 and 1 is 4, plus 5, plus 5, plus 1.
14, 15. Sudoku helps for that cell.
3 and 9 are obviously out. 3 plus 5 is 8, plus another 3 is 11. So this can't be more than 4. It doesn't have enough blue digits looking at it, so I'm not.
Use box 8 for the Sudoku.
Oh, a 1 here takes a 1 out.
Oh, right.
You couldn't put the 1 on
Right.
here, it would need a 2 with it. So that's 5, 10, and now I can't put a 5, so now this one is a 1, and this is maximum 4. That's
And
still
it
a
can't
3.
be 2. Box 6 on the left side of the croppy dot. Because it
1
would
and
see
3.
both 1 and 3. And 4 sees 3, so that's 5.
5 and 2 and 5. That's all of my degrees of freedom. Two, 8, 3, 6, no, 9. 2, 5, 6, 7, 8. Not a 5. Okay. This has to be done on this side because we know that the endpoints have one that they're co-prime with and one that they're not. So that has to be the end of the snake, which means this is a 4. Where's 4 in this box? Not there, not there, not there. Not helpful. This one, not there, not there, not there. Also not helpful. I guess one of those two takes it out of there. Places it here because of those two. And this, and that. Those, 3, 9, 4.
Well, 1 and 7 have to go along the top row because of 1 and 7 X-Wings are in boxes 8 and 9.
Right.
Box 3 pencil marking helps a lot. For a moment, I thought the 4 in box 9 didn't clear the fog. Different puzzle. Yeah, we already did the fog of war earlier.
The 3 9s in here get forced into that corner. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know why I said 9. 1, 1. 6, 7, 3, 9.
Now the snake might be helpful again.
I mean, it's either those two or those two. So it has to be one of these two. If it's here, that's 8, which places 2 and 4. If it's here and there, I mean, we get 4, 8, but that's not exactly helpful. The 4s will line up in place of 4 here. And then the 8s in here will take 8s out of there, placing it there.
Where's the 2 in row 1?
Not there, for a 4. It's in lots of places, possibly.
No, where is it in box 3?
Oh, it is forced up there. Because this is the 3, 9 and the 2's out of those two.
So it can't be the top 2 are blue. Thank you.
These two, 4, 8, those are out. So 4s
So 8
and
comes out
4s, places of
in
4.
box 3.
8 and 8
Oh, 2.
takes 8s out, places an 8. 8's out of that row, 1, 6, 7. Five, not 5.
One. Where's the 1 in box 3? Also, that white Kropke is resolved for ages.
6,
Just didn't think of
7,
mentioning it.
7. I guess the 1, 7 here.
Yeah.
Fixed it. 3, 9, 4, 2, 8. None of these are a 5, so that is. 6 and 7 is out. That's even. This must be odd.
Yeah. 2, 4, or 8.
4, 8. 1, 6, and 7. This isn't a 5. Six takes that out. 1 takes that out. 6 takes that one out.
Yeah.
1, 6, and 7 means we have 2, 4, 8, and 5. This one's not 4 or 8. Actually, neither of those are 8. So that's not a 5. 2, 4, 5 places 8. 2, 8, not an 8. 1, 6, 7 triple.
Row 5 has a 6, 7 pair.
5. 6. 2, 4, or 8, not a 4. 2, 8, 6. This one's not an 8. But that's 2, 6, 8, so that leaves 5, 6, 5. Not a 5 is a 5.
Row 7 needs 5 and 6.
5, 6, 6, 5. Not a 6.
3, 9 pair in box 6.
9.
Removing the gray could make still a bit more visible. Yeah. Because we know the snake shape. Yes, we do.
2, 8. 2, 8, 3, 9. 2, 8 pair. 3, 9 pair. One of these two is a 6.
Column 3
so
has a 1, 7 pair.
Base it's a 6. 2, 1, 7, 6, 2, 4, 2, 8, 4, 8. 2, 8, 2, 8. 1, 7, 7, 8. 6, 1, 6. Not a 6, 7, 6. Probably resolved by the diagonals.
Oh, yeah.
Those two are the same. So if they're 7s, that would be 14, 16, 17, 20, 28, 30. So those could be 7s. But if they were 1s, that would be 2, 4, 5, 6, 7, 8. Oh, wait. 4 plus 7 is 11. Plus 9 is 20. 28. 28 and 4. These can't be 1s, so they're 7s. 16, 24, and
12.
28. 28 plus 9 is 37. So what if this was a 3? 24, 28, 28 and 3 is 31. Wait, no.
Well, those last 3 digits have to sum to 12.
Okay, so that would be a 9 and a 1, too.
Or a 3 and a 7.
A 7 and a 3, too. If this was a 4, those would have to sum to 8.
And they can't.
So that's a 2, that's a 4, 2, 4.
16, 18, 22, 3. Those last 2 have to sum to 16, so it's 7 and 9.
3, 9, 1, 1, 7, 9, 9, 3, 3, 9, 3, 3, and 9. So this one ended up being a 9, 3, 3, and 9. There we go. Ended exactly on time. That was definitely a very interesting puzzle. Yeah, definitely appreciate
along the way.
The leftmost snake digit of each row from top to bottom, where 0 denotes there is no snake cell.
Okay.
Leftmost, starting, going top to bottom. Okay, so that would be a 3, a 9, 4, 8, 3, 9, 9, 3, 4. Yes, success.
I would say that was hard.
Yeah. I feel like we made it harder than it was, though. Now, I definitely think this logic was hard. This was pretty tough, too.
It creates some strong logic on how the snake moves. Yeah.
Yeah.
I really like how the snake has this kind of natural property of alternating 2, 4, 8, and 3, 9, 3. Yeah.
Mm-hmm. Yeah. All right. I don't think there's anything else to... I don't have anything else to say. Let me go with that one. Therefore... anything else that you have, Mama?
No.
Right. Then...
It's nap time.
It is nap time. It's nap time for all of us.
Yes,
although,
Torak, hopefully you managed to get some sleep.
Although it sounded like Torak was waking up at this time, because they couldn't sleep. Yeah, Torak just woke up.
Okay, just woke up. Okay.
But Elytron did say...
able to sleep consistently.
Yeah. But yeah. But Elytron did say that they were staying up, so... yeah, alright, get good sleepies.
Good night.
It is the time of nap. Let's see. Stream end. Thank you for watching. Have a wonderful day. After you have liked, commented, subscribed, shared the video, and rung the notification bell. Alright.